In the valence shell electron pair repulsion theory, the electrons around the central atom are arranged in a way that the electrons are not bonded occupy the maximum amount of space to avoid the repulsion. So, based on this, we have what is called the shape of the molecules, and this is like a three-dimensional shape. And then, depending on the bonding and non-bonding groups around the central atom, we can predict the shape of the molecule. For example, this molecule over here has two groups around the central atom. The shape of this molecule will be linear. This one over here has three groups, 1, 2, and 3. The shape of the molecule is trigonal planar. We could also have three groups where two are bonding pair and the other two are not. And the other one is not. For example, around sulfur over here we have one group, another group. A double bond also counts as one group, and a lone pair. This lone pair counts also as one group. So there are two groups that are bonded, one group that is a lone pair. So now the shape of this molecule is going to be bent. For four groups like this, we have 1, 2, 3, and 4. For all bonding, the shape is going to be tetrahedral. We could also have four groups in this case. Notice 1, 2, 3, and one pair that is non-bonding. In this case, the shape is going to be trigonal pyramidal. And the last case is when we have four groups, 1, 2, 3, and 4. And two are lone pairs. And in this case, the shape will be bent. So we're going to use this table. If we have four groups and 0 lone pairs, this is the shape. Four groups where 3 are bonded and 1 is not, this is the shape, and it keeps going. This table over here will help us predict the shape of the molecules. So the first thing when we are answering these problems is to draw the electron dot formula, arrange the electron around the central atom, and count the groups, bonding and non-bonding, and then refer to the table. So for example, H2S, we learned that the central atom is going to be this one because it can make more bonds. So when we do the electron dot formula, we realize that it looks like this. So we have 1, 2, 3, and 4 groups. Out of those 4 groups, 2 are non-bonding. We go back to our table and we realize that the shape of this molecule is going to be bent. Now let's do NF3. NF3. Central atom is nitrogen because nitrogen likes to make 3 bonds and fluorine likes to make only 1. We're going to do the electron dot formula the same way we did it before. We notice now that we have 1, 2, 3, 4 groups. 3 are bonding, 1 is a non-bonding. The shape of this molecule is trigonal pyramidal. We will have molecules that are polar if we have polar bonds. Any molecule that is completely symmetrical will be a non-polar molecule. If the molecule has something that breaks the symmetry or the presence of a lone pair, then the molecule will be polar. So for example, a molecule like this is symmetrical, is the same on this side and this side. This molecule is non-polar. Something like this is non-polar. Something like this is non-polar. All the substituents are exactly the same. The molecule is non-polar. So in order to determine the polarity of a molecule, the first thing we need to do is write the electron dot formula, then count the groups, and if we have lone pairs around the central atom, that molecule is going to be polar, and if we have a molecule that is non-symmetrical, it will also be polar. So we're going to do all these together, and let's see. Let's start with this one, P, and then once you do the electron dot, it will look like this. With a lone pair on phosphorus. We are going to count the groups. 1, 2, 3, and we have a lone pair over here. The shape of this molecule is going to be trigonal pyramidal. And the molecule is polar. Why? Because it has the presence of this lone pair on the central atom. Let's do the next one, HBr. HBr, the electron dot formula looks like this. This molecule is linear and is polar because it doesn't have any symmetry. Next molecule, Br2, it looks like this, Br with all this. This molecule is linear. Any molecule with only 2 atoms is going to be linear. And this one is non-polar because it's symmetrical, the same on the 2 sides. Let's move to the last one, is SiBr4. Central atom is silicon, and we put the bromines. And we notice that this molecule is tetrahedral, and also is a molecule that all the substituents around the central atom are the same, so this molecule is non-polar.